Hello. Okay, so we're going to do ratio and percent notes today. This should be pretty much review. I know we talked about ratio and proportions. It's going to come up here when we did the similar figures. Sorry, indirect variation earlier this year. And you did percent of a number last year in 6th grade. So we just kind of have to tie that together, and then that's going to lead into our next study about percents. So the TEK that we are dealing with is we're going to solve problems involving ratios, rates, and percents. So that's TEK 7.4D, which was the TEK we did when we did similar figures and things like that, including multi-step problems involving percent increase and percent decrease and financial literacy. Okay, so the financial literacy part, that's the 8th grade TEK that we're going to work on next week. Hang on. Oh, allergies. Okay, so that part we're not going to address till next week. The percent, one more time, hang on. Okay, so anyway, percent increase and percent decrease, we're going to work on tomorrow. That's tomorrow's lessons. But today we're just going to work on these ratios, rates, and percents, and just make sure we remember how to do that. Okay, so remember last week we were doing that grow toy and we looked at the ratio tables, and yesterday you had ratio puzzler to kind of do, so we're just keep working off of that, getting to where we need to be, which is, these learning targets. So by the end, when you're all done with this lesson, you should be able to write a proportion to represent a situation. We're going to talk about a couple ways to do that. You should be able to solve that proportion. And again, when we did this in class, we had about 3 different ways going. So whichever works for you is fine. Okay, and then the last one, I can use a proportion to solve a percent problem. So you're going to solve the proportion, you're going to write the ratio, you're going to solve the proportion, and then you're going to relate that to a percent, because we're going to see or be reminded, however you want to look at it, that a percent is really a proportion. So let's get started. So a ratio, remember, is a comparison between 2 quantities. So I could compare a part to whole, or I could compare part to part. Okay, and we are going to write those as fractions because that's going to be the easiest way for us to do the math. When you did that ratio puzzler, you wrote those ratios in a table. So what you can do is look at the top of the table, bottom of the table, that's your fraction. Okay, so for example, if we have in a classroom, some classroom somewhere in the world where they're not at home anyway, there are 3 girls for every 5 boys. We're going to write a part to part and a part to whole ratio. So when I write this ratio, I find it easier to label as I write. There's a couple of ways you could do this. You could label first and then fill in your table. I'm just going to do it this way for now. I have 3 girls for every 5 boys. Okay. Or I could write 5 boys for every 3 girls. Okay, and these would be part-to-part ratios. Part of the class to the other part of the class. Okay. Now, part-to-whole ratios, you have to do a tiny, tiny little bit of math in here. So they would be like if I say I have 3 girls to 8 students. So where'd I get 8 from? Well, if I have 3 girls for every 5 boys, that means I'm talking about for that total of 8 students, 3 of them are girls. Or I could say for the 8 students, I have 5 boys for the 8 students. Okay, and this is part to whole ratios. Okay, and I think keeping these in mind, part to part to whole, kind of makes it a little bit easier to set up our proportions and our percents if we keep that in mind. Okay, and then of course you could write these 2 blue part to whole ratios. You could write 8 students for 3 girls, 8 students for 5 boys. You could flip these up side down, still a ratio. Okay, so part to whole. And a lot of times, and I know you did this in 6th grade, they'll ask you the part to whole, so you have to realize, oh, if I have 3 girls and 5 boys, that means I have 8 students. Okay, All right, so let's see what's next. Next, we're going to talk about proportions. So if we have two or more, because we have that whole ratio table, right? Ratios that are equivalent, then there's a proportional relationship there. And you can write and solve the proportion to find the missing value. Because it's a proportional relationship, you can also write like an equation, a direct variation equation. Remember we had K, that constant of proportionality in there. And if you graph it, it's going to be a linear function going through the origin. That's all related, okay? So we're going to work on writing a proportion. That's the first step. Once you have it written, solving it is not a big deal. There's a couple different ways you can solve it. Pick your favorite way and go with it. Okay, I'm going to try to show you all three ways that, as I think back to when we did this with unit rate and direct variation and similar figures, the way that you guys were choosing to solve these, okay? And so you just pick your favorite way, do it that way every time. Or sometimes one way, it makes more sense to do it, you know, using your scale factor because you can see it. And sometimes you just want to find the cross product, okay? So we are going to talk about that. Oh, right here. There are a few ways you can solve the proportions. You could use the ratio table and the scale factor like you did with that ratio puzzler yesterday, and like we did with last week, the Grow Toy. We found the scale factor, use that to figure out the missing value. You could find and use the unit rate. A lot of y'all did that. That's not where I go first, but it's not a bad method, and sometimes it works. Like if you're doing speed problems, a lot of you guys, figured out how fast the car was going in 1 hour, and then you use that to figure out how far you can go in 3 hours or whatever. Okay, so unit rate is good. So you can find and use the unit rate. You could find the cross products and solve the equation, and I'll show you that again. That's really useful if you have ratios that don't have a really, I shouldn't say easy, like an integer scale factor. Most of these problems in the 7th grade, on the 7th grade test, have a whole number scale factor, integer scale factor, and you can find it. You just have to do some simplifying, and you can find it. But if not, this cross product works, okay? And when you find the cross product, you then end up with a one-step equation that you solve, okay? All right, and that's how next year in algebra you'll write the direct variation equations and solve them that way. If you choose to, I'll show you, but it doesn't matter to me how you solve a proportion. As long as you use one of these methods correctly, it's going to work. Okay, so for example, Blake downloaded 264 pictures from his cell phone to his computer. These pictures took up 528 megabytes of space on... I changed the name. I'm sorry, Blake. This should say his computer. Sorry. It was Kendra or something. I just changed it to be one of y'all. Each picture took up the same amount of space. How many megabytes do 35 of these pictures take up? Okay, so each picture took up the same. So as soon as I see this, I might be thinking, unit rate. If I find out how much space one picture takes up, then I can just multiply it by 35 to figure out how much space 35 take up. So let's do that, because I know unit rate was kind of a big deal in 6th grade, and I know it's a big deal in 7th grade. The regular 7th grade, not per AP curriculum, deals a lot with unit rate, if I recall correctly. So let's try unit rate to start with. So the unit rate, I would know how many pictures, how many megabytes one picture takes up, okay? So that means I'm going to take my megabytes, divide them by the number of pictures, and one picture will take up, sorry, I have to grab my calculator. You could simplify, you see how 28 and 64, those numbers are both divisible by 4? That means the 528 is divisible by 4, and 264 is divisible by 4. So you could simplify it. I'm just going to grab my calculator quick. 528 divided by 264 gives me 2. So So I have 2 megabytes, I'm just going to abbreviate here, per picture. Okay, so 35 pictures. Sorry, that was my dog. Evidently she has allergies too. Okay, hang on, let me get rid of her. Okay, so 35 pictures times 2 megabytes per picture will give me 70 megabytes. Okay, so that's option 1. Okay, option 2, because sometimes it's not a clear, in my opinion, it's not a clear, oh, it's each, so I'll just find the unit rate. So number 2 is to do the proportion. So I'm going to just write down my information as it appears in the problem. 264 pictures take up 528 megabytes because I am going to compare pictures and megabytes. Okay, that's going to be equal to, let's see, each picture took up the same. How many megabytes do 35? So megabytes, how many? I don't know. So X megabytes, 35 pictures. 35 pictures take up, I don't know how many megabytes. So remember we talked about this when we did similar figures. Your labels have to match either this way, pictures to pictures, megabytes to megabytes. Okay, or your labels have to match, the other way you can make them match is this way. Okay, you just remember you can't have like pictures here and pictures here. Okay, all right, so why do I want to do this? Well, because now, see how I have these nice red lines already drawn? I can find the scale factor. Do I know what I multiply 264 by to get 35? Why? No, I don't. So I am going to simplify. Like I said, I know 4 goes into 264. So I divide that by 4. 4 goes into 26 6 times. Okay, so 4 goes into 26 6 times, that's 24. 4 goes into 24 6 times. Okay. And then 4 goes into 5 once. 4 goes into 12 3 times, 132. Okay, so let's see. I can divide both of these by 3. 66 divided by 3 is 22. 132 divided by 3. Sorry. 3 goes into 13 4 times, so 44. Okay, there we go. And I'm like, this, I don't know if this is going to work, but now I got it. All right, so 11 goes into 22 twice. 11 goes into 44 4 times. Oh, I guess I should have. Okay, so here we are. 1 half. Okay, so 1 times 35. Let me move this up. So let me. So sorry. So I know that one picture, again, takes 2 megabytes. That's what I found out from all my simplifying up there. And so then 35 pictures, and I have X megabytes here. Okay, so I figured out that 1 times 35 is 35, so 2 times 35 is 70. So X equals 70, okay? Remember when we did this, we called this the scale factor K, constant of proportionality. That's how it's all kind of related. Okay, so that's the second way you can do it. And then the last way is really similar. I'll use green. Let me move this up again. Similar in the way that I'm going to start the same way. 264 pictures. 528, if I write that correctly, 528 megabytes. And you could do like, oh my goodness, sorry, I'm scratching my eye and I missed. 264 pictures, 528 megabytes equals 35 pictures to I don't know how many megabytes. So that way I get my labels in there and I see they match. Okay, so what I'm going to do here is find the cross product. Okay, so I'm going to erase these labels so they don't confuse us, because what we're going to do when we find the cross product is get an equation. We're going to end up writing an equation, so I only want one letter, so to speak. So cross products, I'm going to find the cross product. So 528 times 35 is, I need my calculator. Oops. Calculator, 528 times 35 is 18,480 equals this cross product, 264x. I get rid of the coefficient by division since that undoes that multiplication. 264 divided by 264 is 1x. 18,480 divided by 264 is 70. Okay, so any way you do it. So that's all three ways. I know that was a lot, but I just wanted to make sure we remembered all the different ways that you can solve this so that you can pick what is easiest for you. Okay, so percent of a number, that brings us to percent of a number. Oops. Trying to do that. Okay, percent of a number. Percent means out of 100. And I know we struggled with that on that Grow Toy, that very first slide, first day. I said, what percent is this? If whatever we're starting with, the original amount, that's 100%. That's our whole. And then we're going to see what happens with that. Are we going to be adding tax because we're shopping? That's a percent. Or tip because that's a percent. Or are we going to be deducting because I'm saving money? I have a 20% off coupon or something like that. Okay, so the 100% is where we start. So therefore it's a ratio because we are always comparing our situation to a number out of 100 for percent. Okay, so when we find percent, we're dealing with proportional relationships since we are comparing a ratio to a ratio out of 100. So there are three different examples, and I wasn't sure I was going to leave these in here. Evidently, I decided to. You can find the percent of a number. Like I could say, what percent is 10 out of 90? For whatever reason, I might want that. Maybe I'm trying to figure out what percent... maybe I'm earning a commission and I want to know what percent I'm getting paid. So I know I got, $200 out of the $2,000 object that I sold. So what percent is that? You could find the percent that is the number that is the percent. For example, what number is 15% of 25? That's what you're doing when you're trying to find tax. How much is 8.25% of $50? How much is, if I want to leave a 15% tip at the restaurant and my bill is $62, how much is that? Okay, so that's probably the most common way people use percent out there in the real world. Or you can find the number that you started with. 20 is 15% of what number? Okay, so that might be, let's see, when would you want to do that? If you know that you have, I don't know, I'm trying to think of a situation here. I have 20, I always go money, $20. And I know that's 15% of what I need. Or maybe someone's raising money and they have raised $200 and they say we're 25% of our goal. And you want to know, okay, so I don't know if I finished that thought, but if I wanted to know what the goal was, if they're 25% of the way to their goal, I wanted to know what their goal had been, I would use the, 20 is 15% of what number. Okay. Let's look at an example. So Gabriel is a collection of 2,400 pennies. Of these pennies, 20% are dated before 1980, 30% are dated between 1980 and 2000, and the rest are dated after 2000. And we want to know how many pennies in this collection are dated after 2000. Okay, so let's see. I start with 2,400 pennies. That is 100%. Okay, so guess I would start with writing the proportion. So 2,400 pennies. And that represents 100% of my total. And there, if you look this up, there's a whole bunch of different ways. Some people put it in a little like a little chart like this, and they always put the 100 here and call that the percent, and this the number, call this a part, call this the whole. That's fine. That's why I used to teach it, but I'm going to try to do this the way we did the last problem and see if we can do this. Okay, so the rest, I don't know how many they are. How many pennies? So that's what I don't know. So X pennies, and I want to know how many they are, so I need to know the percent. Well, if I had 20% before 1980, 30% in between, and then I have the rest, I need to know what percent that represents. So 20% plus 30%, that gives me 50%. That means the remaining 50% are after 2000, okay? So that's here, 50%. Okay, so a couple different ways I can do this. What I'm going to do, because right here I see really quickly that 50, or 100, go that way, divided by 2, or times by 1/2, is 50. So 50 is half of 100, so I need to find half of 240, okay? So divide that by 2, divide, and it looked like a percent sign there, divide by 2, or times by 1/2, so half of 2,400 is 1,200. So he has 1,200 pennies that are dated after 2000, okay? So let me show you this, because if you do go to the internet for some help, you are going to see this kind of a lot. Okay, so we did a little like ratio table, and they're labeling this percent, and this is our number, and then we are talking about the part to the whole. So the whole collection is 2,400, and 100% always represents the whole. And this is kind of what we did in the Grow Toy too. I kind of set it up this way. Okay, the part is what I'm looking for, but I know the percent of pennies after 2000 are 50. Okay, so a couple different ways you could do this. You could say, well, 100 times 24 gives me 2,400, so I can do 50 times 24, and that will get me I'm sorry, 50 times 24. Hang on. I'm thinking about there, 50 times 24. 1,200, yeah. Sorry, I blanked for a moment about the whole percent and decimal thing. All right, so 1,200, so X is 1,200. So you can do it that way. Or you can always look within your proportion too. I could still say here, well, 50 times 2 is 100, or I guess I need to go the other way since I'm missing that X is in the numerator there. So 100 times 1/2, or divided by 2, is 50, so 240 divided by 2, again, is 1,200. Okay, so any way you do that, the important part, I think, if I had to say what is the important part, is that is your whole amount. That's going to be there, so that you will be missing one of these numbers. You'll either, like we said before, you'll look for the percent, you'll look for the whole number, the 100% number, or you'll look for the percentage number. Okay? All right, so either way, you could, unit rate wise, this is where you had learned 10% method, 1% method. You could take this down to 1% would be how much, so then 50% times by 50, you can do it that way as well. Okay? All right, and then if this is a strange sort of percent, like, I don't know, sometimes they give you like 17%, your cross product will work as well. So to do that, you would have, hang on, I was on the highlighter instead of the pen, 2400 over 100 equals x over 50, just rewriting this proportion here. You could do 2400 times 50 is 120,000 equals 100x, and then, can't get, the rest of this won't move, there it goes. Okay, and then divide by 100. To undo that multiplication, that equals 1x, and that equals 1,200. Okay? Alrighty, so that's that. Let's look and see how you did. So here's your learning targets again. Can you write a proportion to represent a situation? Did that make sense? Did you remember how to do that? I really think labeling is the key there. Can you solve a proportion? And we talked about the 3 ways: unit rate, scale factor, or find the cross products and solve that equation. Can you then use that proportion to solve a percent problem? Do you know where the 100 goes? Like, there always has to be that 100%. That matches up with your original amount, the whole amount you're starting with, or what it was originally. And that original part is going to become important tomorrow when we talk about percent of increase and decrease. Okay, if you're looking at these going, no, then you need to probably watch the video again. I am going to put this in Edpuzzle so I can ask you some questions along the way. I know you can't redo the questions, but I think you can still see the video. So let me know if you can't. I'll send you the link for this video before I put it into Edpuzzle. Okay, and then if you have questions, of course, email, comment, Google chat. Let me know, okay?